Welcome to the Math Record. Today we'll be learning about vectors in 3D space. This video will cover part 4 of chapter 9 in our Precalculus class. In our previous chapter 9 videos, we had 2D vectors in the form v is equal to ai plus bj. Now, since we're in 3D vectors, we just had to add the x-axes. So now we have vector is equal to ai plus bj plus ck. So I would be the change in x, j would be the change in y, and k would now be the change in the in z. So now so the ck would be like just the new term for the x-axis and how we're gonna like calculate stuff for it now. Sorry. Now let's move on to the properties of 3D vectors. This is similar to like of 3D vectors, which is similar to like 2D vectors, but now we just have the z-axis. So we have vector like ai plus bj plus ck, and u is equal to like di plus ej plus fk. Then Then basically, if you wanted to add vectors now, so v plus u, it's like the same concept, just add the x together, so a plus di plus b plus ej plus c plus fk. So it's the same concept. Now you just have the z-axis. So it's v minus u, a minus d I plus b minus ek, I mean j, plus c minus fk. You know, it's just basically that simple. It's just like 2D vectors, but now you just have the z-axis, as I said before. Also, like if you're scaling it, like you have a as a scalar, so it's like 2v or something. Then basically you just have like ai plus a bj plus a ck. And now, if you want to find the magnitude of a vector, you just have to add their variable. So the magnitude of a 3D one, which is just we just have the square root of a squared plus b squared plus c squared. Because 2D was just a squared plus b squared. Now 3D vector is a squared plus b squared plus c squared. Like this could be like easily explained. Like let's say you have like a square, right? And you have this a and this b. Then to find the hypotenuse, just a squared plus b squared, right? And then square root it. That's the hypotenuse. Now if you have like a 3D object, right? And you have from this point to this point, and you have to make that line. All you had to do is just find a squared, b squared, which gets this line on this base, and then you just go up. So this line plus this line plus this line squared, this line squared plus this line squared, it would just get that. Since this hypotenuse line is just a squared plus b squared, and you square root it, right? And then you just square it again, which is just a squared plus b squared, plus the last line, which is c squared, square root. And that's how you get a squared plus b squared plus c squared. It's basically just that simple. If you just think about the shape, then you will never forget how to find the magnitudes for like 2D shapes and 3D shapes. And the process to get the unit vectors for 3D shapes is also the same, which is just v divided by the magnitude of v. So for example, we have like v is equal to ij plus 2, I plus 2j plus 3k. So the magnitude is like 1 squared plus 2 squared plus 3 squared. So 1 squared plus 2 squared plus 3 squared. Square rooted, that's 1, that's 4, that's 9, that's 19, that's 13, that's 14. So that's square root 14, right? So now you have I plus 2j plus 3k divided by square root 14. So it will be 1 over square root 14i. I plus 2 over square root 14j plus 3 over square root 14k. So this would be the unit vector version of v. which is just the same case. You just had to, which is just the same process basically. Okay. Also, like the dot product for the 3D, it's kind of the same, but now you're gonna be doing it like with the Z. So you also have the original was U is equal to AI plus BJ, and V is equal to CI plus sorry, I'm just gonna use D. DI plus EJ, and it's just AD plus BE, right? You multiply the X, multiply the Y, and add them together. Now it's the same concept. You have to add CK, and then add FK. So now it's just AD plus BE plus CF, right? So you multiply the X, multiply the Y's, multiply the Z's, and you add them together. And you basically have the dot product for the 3D vectors. Which is also the same way to work with to find the angle between like the 3D vectors, which is like cosine of theta is equal to the dot product of u and v divided. Sorry, the dot product of u and v divided by u, the magnitude of u, and the magnitude of v, right? Multiply those together. So it's basically like the same concept, but now with just the z. Um, and a new concept that we're gonna talk about would be directional angles, because you can't have this in 2D space, because like let's say you have a 2D, right, and you have an angle right here and an angle right here. You only find this angle or this angle around, which is unnecessary because you already found this angle because this is 360 degrees, so you just find the angle really easily. But now in 3D space, right? Let's say you have a line right here and a line like somehow like this, then you could like there is direction. I mean you have a line right here. There is a you only have one line, which is one vector. There is three angles now, which is in the x, the y, and the z. So there's an angle for the z, there's an angle for the x, and the angle for the y. So there's three angles, which is called the directional angles. Okay. To calculate these angles, they're basically like a general form. So let's say you have cosine A. It's divided by A divided by the magnitude of the of V, and cosine B divided by B by the magnitude of V, and cosine C is C divided by the magnitude of V. So the vector would just be AI plus BJ plus CK. So if you wanted to find, since this is the x and this is the y and the z, right? Then basically, if you wanted to find the x, you just put the coefficient in front of the I divided by the by the magnitude of the vector, and then find the inverse cosine of that. And you just do the same thing. It's just the same process. So you want to find the y one, just put in the b. You want the z one, just put in the c. This is basically the same thing. I'm just showing like it in all three in different ways so you understand how it works. But it's just the same idea. Just put the coefficient and find the variable that you want, and then divide it by the magnitude of the vector, and then inverse cosine of it using your calculator, and you'll get the angles. And those are the three directional angles. Um, These directional angles also have this unique property that if you have cosine squared of A, cosine squared of B, plus cosine squared of C, all these add up to 1. It's a pretty unique property that is sometimes utilized, but not as often. Also, how to write 3D vectors in polar form. It's also basically the same idea. Like 3D vectors and 2D vectors are really similar. You just add the I might be repeating this like 20 billion times, but it really is true. You're just adding the z-axes. So now it's just the magnitude of v times the cosine of AI plus cosine of BJ, and also the cosine of CK. See, now you have the z-axis again. And if you wanted to get these angles, cosine A, cosine B, and cosine of C, well, you do. I mean, not the angle. To get the if you want the angles like A, B, and C, it's just from the directional angles. So cosine A, cosine B, and cosine C is basically the same thing as saying when we had the vector AI plus BJ plus CK, then cosine of A would just be A over the magnitude of V, or B, and cosine of B would just B over the magnitude of V, and cosine of C is just C over the magnitude of V. Because as I said before, it just equals just cosine C, cosine B, right? This is cosine B, and this is cosine A. So basically, you just do that. You just find the angles. Which is basically just that simple, really. So these are just directional angles. So that's just how you get the polar form. You just find the magnitude, which is really easy since you have V is AI plus BJ plus CK, which is just A squared plus B squared plus C squared, and the square root, the entire thing is the magnitude. And then to get the directional angle, just have the coefficient in front of that variable divided by by the magnitude of the vector, and then find the inverse cosine of that, which gets the angle. But you don't have to find the inverse cosine because the cosine of that angle is equal to like the coefficient divided by the magnitude of the vector. So you just find A divided by B, or whatever the coefficient you want to find it, A, B, or C, and that'll give you the angles of X, Y, and Z, which is really just that simple. Well, that basically covers everything for 3D vectors. In general, it's basically just the same as 2D vectors, but now with just the z-axis. Well, thanks for watching, and I'll see you at the next math record video, which is probably going to be the final video in the Precalculus class.